This is the same problem that we did last week. 3x plus 1/4 plus 7/8 is equal to 8.5. What I'd like to do is I'd like to solve this problem one more time. First thing that we should do here is bring these two like terms together. So let's show the work right up here. Let's add 1/4 plus 1/4 plus 7/8. Let's add the 1/4 plus the 7/8. Something that we've talked about in the past is to add these two fractions, you must have a common denominator. The way you find the common denominator is you start with the larger number and you ask yourself, can 4 go into the 8 evenly? In other words, you ask yourself, can you multiply a number by 4 to get 8? And you can. Yes, you can. You can multiply 2 by 8. That means that 8 is your least common denominator. Or sometimes you hear it called a least common multiple. All right, so you multiply this by 1 to get 8. You multiply this by 1 to get 7. You multiply this by 2 to get 8. And you multiply this number by 2 to get 2. There's no difference between 1/4 and 2/8. It's the same value. 1/4 has the same value of 2/8. You add these fractions together and you get 9/8. You get 9/8. So now what we're going to do is we combine these two terms. They're called like terms. We combine them and you're left with 3x plus 9/8, because 1/4 plus 7/8 is 9/8, is equal to 8.5. And another way we talked about last week, another way to write 8.5 is to keep the denominator of 2 and multiply the 8 times the 2. You get 16. You add the 1 and you get 17 over 2. So just a little recap. What we did was we combined these two terms. They're like terms. We added them together. We got 9/8. We added them together. We got 9/8. And then we wrote 8.5 in a different way. We wrote it as an improper fraction. Denominator of 2. We multiplied 8 times 2 to get 16. You add 1 to get 17. Now, you're doing inverse operations. You're adding. Let's subtract 9/8. Subtract 9/8 on both sides. And again, you need a common denominator, which is 8. We've already gone through how to find a common denominator. So the denominator is 8. Let's multiply this by 1. You multiply that by 1 to get 9. Multiply this by 4. And then you multiply 17 by 4. And 17 times 4, let's show the work. 17 times 4, you get 28. Carry the 2, you get 6, 68. All right, there's no difference between 17 over 2 and 68 over 8. It's the same value. Now you're going to subtract 68 minus 9. Let's show the work. 68 minus 9. You subtract, you get 5, you get 9, you get 59. All right, so what we have is we have this canceled. We're left with 3x is equal to 68 minus 9, which is 59 over 8. And now we're almost done. Let's solve for the x by multiplying by 1/3 on both sides, or you could divide by 3. It's the same thing. Multiply by 1/3, and you're left with x is equal to 59, multiply across, over 24. And 59 over 24 simplifies to 2. 2 times 24 is 48, and then you're left with 11/24. 2 and 11/24. Final answer. Okay, final answer. So that's an equation that I made up for a special reason. I created that equation especially because it models something that you could possibly see in real life. We're trying to draw a connection between algebra and something maybe you could see in real life. So let's take a look. Let's take a look. So again, we have 3x plus 1/4 plus 7/8 is equal to 8.5. Maybe that 8.5 looks like a familiar number, eight and a half, if you think about it, 8.5, the dimensions on a sheet of paper, are across this way, that's 8.5 inches. That's 8.5 inches. So the 8.5 in the equation that I just gave you represents the 8.5, which is the width of a sheet of paper. So let's take a look at this equation and let's give you a better idea of where that equation came from. All right, so look what we have here. We've got 3x. This is the equation that we just solved. The equation that we just solved was 3x plus 1/4 plus 7/8 is equal to 8.5. That's the equation that you can't see that. That's the equation we just solved. And the answer that we got was 2 and 11/24. That's what x has to be to get 8.5 there. So let's try to get a picture of what this represents. Well, what this represents, again, this 8.5 represents the distance. Let's see if we can pull out a little bit. Okay, let's see. All right, that's good. All right, so this 8.5 represents the distance from this side of the paper to this side of the paper. This 8.5 represents the distance from this side of the paper to this side of the paper. All right, so let's act like we are a publisher. All right, let's act like we're a publisher. And one side of a border is 1/4, and another side of the border is 7/8. Whenever you look at these textbooks, the textbooks generally have a width of 8.5, and they always have borders. And then you have the print in between the borders. I hope you understand what I'm saying. Let's take a look. So let's say that this border from here to here, from here to here, let's say that border is 1/4 of an inch. That's what that represents, 1/4 of an inch. We said from here to here is 8.5. The width all the way across the paper is 8.5. That's what 8.5 is. But 8.5 is equal to something. It's equal to 1/4, which is from here to here. Let's say that this 7/8, let's say that that's another border, 7/8. Let's make that a little bit bigger. So let's say that this is 7/8. All right, so from here to here, that's 7/8. And then so we've got the 1/4, that's the left border. We've got the 7/8, that's the right border. Now, what does this 3x represent? Well, this 3x represents the pictures. All right, so let's say we have 3 pictures. Let's say we have a picture here. Let's say we have a picture here. And let's say we have a picture here. All right, so let's call this the width of this picture x. Let's call the width of this picture x. And let's call the width of this picture x. All right, so in fact, let's make this a little bit larger here so we can all see it. Let's say this is 7/8. Let's adjust this just a little bit. Let's adjust this picture just a little bit. Let's make that a picture. And let's make this a picture. Sorry about that. All right, so that's x, and that's x. And let's say that this border is 1/4 from here to here. And let's say this border from here to here is 7/8. Okay, so again, that's 7/8 from there to there. And this border from here to here, let's say that's 1/4. And let's say you wanted to know if you wanted these pictures to be the same distance across, how wide would each of these pictures have to be? Well, that's what we just found out. This picture would have to be 2 and 11/24. This picture here would have to be 2 and 11/24. and this picture here would have to be 2 and 11/24. All right, so we've got one border, which is at 1/4. We've got another border, which is 7/8. And again, if you wanted these pictures to be the same width all the way across, what we just calculated is the distance, the width that each picture would have to be.